let's just break this apart. Your sine curve, it cannot fail a vertical line test. So I always go to quadrant 1 because everybody's positive, and I cut it off. When I go to fail, I come back, I cut it off. So for sine, what's my restricted domain? 1 and 4, quadrants 1 and quadrants 4. So I'm going to go from negative pi over 2 to positive pi over 2. Whenever you do inverses, this is where I want you to start. Before you even look at your stuff. As soon as you see inverses, write that down. So whenever you see inverses, start like this. So let's go to tangent. Tangent says, well, you can't use 90, you can't use negative 90. Your tangent curve goes somewhere in the middle. So what quadrants does tangent use? 1, everybody uses 1, and what's the guy before 1? 4. So now tangent says, yeah, you're good with this, but you just can't use the negative 90 or the positive 90 because we don't have a tangent for that. The last guy is cosine. Cosine starts up at the top, so we can't go backwards. But we come down here, this is quadrant 1, look at its positive. When we go to quadrant 2, it's negative. So what's my restricted domain? So if you think about a unit circle from here to here, quadrants 1 and quadrant 2, what's the domain? 0 to pi, right? Quadrants 1 and quadrants 4. If I'm doing 1 and 4, well, I can't come all the way around to get there, so I got to go from here to here, from negative 90 to positive 90. So it makes sense if you do this first. Okay? Now, these I just wanted you to put in your calculator. Not a big deal. These guys, let's start with these guys. Keep track of this, because I have no way to keep them there. I have to move them. Keep track of this. Parentheses first, just like when you did this. If I gave you two equations, and I gave you a composition, and I said f of g of 2, what would you do first? You would do g of 2. So you would find this answer, which would be what? 0. And what would you do with 0? You put it into f, so then you would do this, right? So you're doing the same thing. These are just compositions. These are compositions. Start at the right. You're going to refine arc. Arc means what? Restricted, right? Anytime I see the word arc or sine negative 1, I see the negative 1 or I see the arc, that means restricted. Everybody's positive in what quadrant? 1. So this puts me in quadrant 1. And I don't care what my angle is. My sine, okay, make it 7 over 10. Doesn't matter. 0.7 over 1. Doesn't matter, because you're going to see in a minute it doesn't matter. 0.7 over 1, if you like to do it that way. Just make it simple. Oh, I located this guy. Now what do I want to do? Find the sine of this? Isn't that the sine of an angle? Isn't this the sine of the angle whose sine is 0.7? We did an example like this. It canceled itself out. So the answer was 0.7. It was that simple. The cosine one does the same thing. I have a restricted angle whose cosine is negative 0.3. What's the cosine of that triangle? Negative 0.3. It kind of canceled itself out. Let's get to these guys. I start at the right. Oh, where the heck is 3 pi? Where is 3 pi? I know this is 0. I know this is 1 pi. I know this is 2 pi. And then this guy must be what? 3 pi. This is at a quadrant. I know my quadrant. So I located 3 pi, any angle, 3 pi, it just says the sine. What is the sine of this angle? 0. So I replace this with a 0. And now I say a restricted angle for sine where the sine is 0. So restricted angle, what quadrants is sine? 1 and 4. Anything for sine and cosine that use a 1 and 0 are your quadrants, because that's where we graph your sine curve from, right? The 0, the 1, the 0, the negative 1, the 0. So those are your mins, your max, and your zeros. So I just label this again. I'm looking for sine to be my y value. Which one of these y values is 0? This guy, right? And what's that angle right there? Yeah. 0. That one, I gotta tell you, whenever it's an angle of 0, the kids are waiting for a different angle. They don't give me 0. They'll give me pi, 2 pi. That is 0. Whether you call it 0 radians or 0 degrees, it's still 0. Okay? Good so far? So when I look at this guy, what is this asking me to do? The tangent of this angle. So where is this angle located? Okay, because you knew this was 6 pi over 6. So Jeremiah said quadrant 4. Yep, that makes perfect sense to me. 6 goes into 180 how many times? 30. So let me label what I know. So now, I may need to know whatever it is that they want me to know about this. So I look to my left, and it says tan negative 1. When it says tan negative 1, do they want an angle, or do they want some kind of a ratio? They want a restricted angle. They want a restricted angle. If I see arctan, an angle whose tan is, or tan negative 1, an angle whose tan is. So I take my tangent of this guy. My tangent, I didn't find it yet, so my tangent is y over x. 1 over radical 3, but this is a negative. I plug this in here. So now it's asking me this. What restricted angle has a tangent of negative 1 over radical 3? Tangent is restricted to what quadrant? Oh, miraculously, I'm in the same area, aren't I? But I need to name this angle. It can't be 11 pi over 6, because this says, oh, you're restricted. You're restricted from here to here. So how can I name that same angle? Negative pi over 6, or negative 30 degrees, right? Okay. Just work it one step at a time. You'll see that it's there. All right, let's try some more. Where do I start? So where is 5 pi over 2? 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Same as 90. What is the sign of that guy? 1. So I'm going to take this out and put a 1 in here. Now it's saying, sine negative 1 of 1. I have a restricted sine curve. Where is it restricted to? That it's positive. This must be one of my quadrant angles because it's a 1 or a 0. So I'm restricted to 1 and 4. So again, I go do this. So it's 90 degrees. Wasn't it in the same exact place? But before, this angle was not restricted. It could be any angle. It was 5 pi over 2. In the little part that I want to look at, it's the same exact location, but it's from negative pi over 2 to positive pi over 2. It's pi over 2. Making sense? Not making sense? Okay. I look at this guy. I see the right-hand side first. That's just a regular angle. Where's pi? 5 pi over 4? Quadrant 3. This is 4 pi over 4. 4. This is 8 pi over 4. So this is 5 pi over 4. 4 goes into 180, 45 degrees. So what is the tangent of this angle? 1, because it's negative 1 over negative 1, 1. So I'm going to take this out and put a 1 in there. And basically it's looking for the same thing it looked for there. A restricted angle whose sine is 1. And guess what? If I put this in my calculator, and I say, let me put my mode in degrees so we can see it better. Second sine 1, it tells me 90 degrees. Remember, your calculator does your restricted angles.
It has to be a what mode?
Well, if you want to see it in degrees, watch what happens if I put it in radians. I mean, it still gives you the right answer, but what happens here is you don't recognize it because it's going to come out as a decimal. It's going to come out as pi 3.14 divided by 2. So it's not as recognizable in radians, so just flip it to degrees when you want to look at it. Your calculator does the restricted angle. I could put this whole thing in my calculator if I wanted to, but I need the work shown, so we got to show a little work here. Now, I'm here first. Arctan 4 over 5. Did that say 4 over 5? 4 over 3. What does that mean to me by itself? Restricted angle, whose tangent is 4 over 3. It's positive. What quadrant am I in? 1. I'm in quadrant 1. So I drop a triangle in quadrant 1, and I label it y over x. Y over x. God bless you. Can I find my missing side? Pythagorean theorem. And what's that special triangle? 3, 4, 5. Okay, so I got to get the tangent of this guy. So I got to get an angle whose tangent is that. Now, it's not my special angle, so I'm going to hold off on finding that angle. Because what do I actually want from that angle? The sine. So I'm in this little place right here. So what is the sine of this angle? 4 over 5. That's all I want.
So for the ones that aren't the special right triangle, you just do the fraction.
Well, chances are when they're not a special right triangle, they're not going to ask you to find the angle because it's not one that you could readily find. You'd have to pick up your calculator.
Yeah.
I mean, we could absolutely ask you to, but that's not our goal. So when they do ask you for that, label the parts and just see what they want. Chances are they want another trig function.
Okay.
Like a tangent, a cosine, a cotangent, something. Kind of like this. Arc sine, it's positive. I want an angle whose sine is 24 over 25. It's positive. What quadrant am I in? 1. So 24 over 25. I never will know this angle. But all I want is the cosine of this guy. So cosine, I need to find this little part. I find it with Pythagorean theorem. I find that it's 7. So can I give it the cosine now? 7 over 25.
So how do you know when to find it? Actually, going to have an angle answer.
Because out here, it's going to say arc cosine.
Okay.
If it says arc or cosine negative 1, then I need an angle. So whenever you see the words arc something or with a negative 1 something, I need an angle, a restricted angle. Whenever it just says tangent, sine, you just need the function, the ratio, the fraction. Okay? This guy, I start right here. I say I have a restricted tangent, and my restricted tangent is negative. What quadrant is my restricted tangent? 1 and 4, and so 1 is everybody's positive, so 4 must be where it's negative. So I drop my triangle in quadrant 4. I label my parts, y over x, and I don't know what they're going to ask me yet. So I found this. I say, okay, oh, they want the secant. The secant is the reciprocal of which one? Cosine. So if cosine is x over r, then secant is r over x. So therefore, I'm going to have to find my radius, because I need to use the r. If they just asked me the cotangent, I was in business. Or if they asked me the tangent, I was in business. But they asked me something that uses a radius, Pythagorean theorem, find your radius. Then find your r over x. Remember the arc, the signs with the negative ones, they're restricted. This guy, where is cosine restricted negative? 2. I drop a triangle in 2. X over r, 2 over 3. So I don't know yet what they want. Oh, they want the sine of this. So I need to find the y value. So I need to say 3 squared equals 2 squared plus b squared. And b squared is going to be equal to 5. Therefore, b is equal to radical 5. And then I find sine radical 5 over 3. Is sine positive or negative in quadrant 2? Positive. Because sine uses the y value. Good? And that was it for that one, right? That was it for that homework? All right, so let's end. What quadrants am I restricted in for tangent? 1 and 4, and out of 1 and 4, which one's positive? 1. So I start like this. I drop a triangle in 1. I label y over x. Do I recognize this to be a special triangle? No? Why? Because square root of 2. I have square root of 2, but that would be a 1, 1 radical 2. So this is not a special triangle. So let me just leave it where it is first and see what they want. Maybe they just want tangent or cotangent, and I don't have to find the missing part, right? So I look to the left, and I say, oh, they just want the tangent. So what is the tangent? 1 over radical 2. These kind of negated each other, didn't they? Yeah, so it's 1 over radical 2. Yes.
But you don't have to do all that work.
You can just cancel it all out. Yeah. But you know what? If you don't see it, you draw it. And I wouldn't fill in the missing part until I went to see what they wanted. Because maybe they just even wanted cotangent. And I didn't have to go through Pythagorean theorem. Okay, Alicia, the second one. Where do I start? What's the first thing I'm going to look at?
Oh, there's a restriction. It's the arc.
Okay, but that's last. Where am I going to look first? Start at the right.
Yeah, there, cosine.
So where is 60 degrees? First quadrant, good. So I'm going to label my 60 degrees. Radical 3, 1, 2. Sound good?
Yeah.
Now, I look to my left. Oh, but I want an angle whose sine is. So therefore, I'm going to have to find this guy's cosine. So what is the cosine of this angle? 1/2. Good. So now, I just replace this with the word 1/2. So now I say arc sine a restricted angle. Where's sine restricted to? What quadrants? 1 and 4. And where's the positive? 1. This angle has a sine of 1/2. So it's opposite over hypotenuse. What angle is this guy? 30. And 30 goes into 180 how many times?
6.
Pi over 6.
So
Good.
it has to be in radians like that. You can't write it in 30 degrees.
Well, if I ask for it in radians, then you have to write radians. If you write 30 degrees, you know, as long as you get where it is right now, that's the most important part. And then you can worry about the radian part later. Yeah. Okay. So Jen, number 3, what do I look at first? Arctan. Arc means special, right? Restricted angle. So where is tangent restricted to? What quadrants? 1 and 4. And where is it positive? What? Out of 1 and 4, where is it positive? 1. Everybody's positive in 1. So I say tangent is y over x. Do I know the missing side? 2. Okay, now I go to my left. Oh, I want the sine of this guy. I know exactly where I'm looking because we just labeled the triangle. What's the sine of this? Radical 3 over 2. Sine is y over r. You guys need to remember these special triangles. Okay. Next one. Monasia, where do I look first?
Look at arc sine first.
Arc sine. So where is sine restricted?
Sine is restricted to pi over 2.
Pi over what quadrants?
Quadrants 1 and 4.
1 and 4. So out of 1 and 4, where is it positive?
1.
1. So now I label y over r. What's my missing side? 4. So let me see what they want. Oh, they want the tangent of this guy. So what's my tangent? That's it. That's the answer to the whole thing.
Wow.
Okay, Gabe, what do I look at first in number 5?
The arc cosine.
Oh, where's cosine restricted?
2.
2, and what other quadrant?
1.
Good. Everybody's 1 always. So where is it positive out of 1 and 2?
1.
So I don't need this guy. So cosine is x over r. What's my missing side? Mm-hmm. And what part do I want of that little triangle? Tan. What's the tan?
4 and 3.
4 over 3. It was almost like this one. I just reversed it. Right? They're cofunctions. Okay? Good. Not bad. Okay. Hetzel, where do I look in number 6? Oh, okay, so a tangent is restricted to what quadrants? 1 and 4, and where is it positive? 1. So, the easiest way to do this is to unrationalize this guy.
Is it always going to be like everything is always in 1?
Everybody that's positive is in 1. That's how simple it is.
That's what we're always looking for?
Anything positive is in 1 of the restricted angles. And then sine and tangent are negative in 4, and cosine is negative in 2. Basically, that's all you have to remember. So now, tangent is 1 over radical 3. What's the missing side? 2. And what's the sine of this guy? 1/2. That's it. Right? Okay, well, if you did this, guys, come on. Radical 3 over 3, you have to find the missing side. So this was 3 squared equals radical 3 squared plus b squared. So this is 9. So this gives me 6 is equal to b squared. This is radical 6.
Wait, how did you get the 3 there? Because I got it. Wait, but is it tan 6? The one next
This
to it
more.
and then the one across from it?
This morning. I don't wash my hands.
Yes.
Not the hypotenuse?
Okay, wait, repeat this. Where are you? The left side or the right
6,
side?
right?
I'm in number 6, yes.
Yeah, because it wouldn't it be opposite over adjacent?
Yeah.
You put
Oh, opposite. Oh, I put the 3 there. Sorry about that. I was wondering why this came out so weird. Okay, so radical 3 squared plus 3 squared equals r squared. So this would become out 3 plus 9. This is radical 12, which is 2 radical 3. Okay, I can go home now. All right, so now, when you find the sign of this guy, sign says 3, radical 3, over 2 radical 3. So now when you reduce it, what happens to the radical 3's? And so you reduce to 1/2. It's easier if you can unrationalize it first. It's your special triangle. So I'm kind of crooked there, I'm sorry. Okay. All right, this guy. Nisha, where do I start? This guy. So what quadrant is tan restricted to? 1 and 4. Now you notice that the tangent was 0, so it's probably one of these guys. Also, if it helps, visualize your tangent curve. Your tangent goes like this. Where does it cross through? Where is it 0? At the 0. Isn't it y over x? If I wrote this right. Y over x, isn't that the 0? This is backwards. Okay, I'm talking and writing at the same time. I'm going too fast. So here's my angle. So I'm right there at angle 0. So now, what's the cosine of, let's just say 0 degrees? What's the cosine of 0 degrees? The cosine is the x or the y? The x. 1. Good?
Oh wait, I got it right. But I got it right the wrong way. You got it right the wrong way. Yeah.
Sometimes it's confusing when we write 0 radians. Kids think it means the 0 for the 1, 0, the negative 1, 0. They think it's the 0 there. So if it helps you, just write the 0 degrees. So when I start this guy, I say, is there any restriction on this angle? No. Nope. So where is 3 pi over 2? 1 pi over 2, 2 pi over 2, 3 pi over 2. That's 0, negative 1. So what is the sign of 3 pi over 2? X, Y, cosine sign. Negative 1. So I'm going to take this out and replace it with a negative 1. So then my problem's going to read this. I want a restricted angle whose cosine is negative 1. Cosine is restricted to 1 and 2, and it would be right here at the pi, at the 180. Okay? All right, let's take a look at your other sheet where we're struggling. Okay, the first one. What is the first one asking me?
What is the value?
What's it asking me to find? Do I need to find an angle or do I need to find a ratio? An angle. Art says a restricted angle whose sine is negative radical 2 over 2, which is the same as negative 1 over radical 2, unrationalized. And you should know that angle by now. What angle is radical 2 over 2? 45. So now, I am an angle that's restricted for sine. And always write at the top of your paper, sine. Where is it restricted? 1 and 4. So 1 and 4. So where is it going to be negative?
4.
4. And what angle did you tell me this was? 45. So how do I name this from here to here? Negative 45 degrees for negative pi over 4. Okay? The second one, I want a restricted angle whose cosine is 0. Cosine is restricted to what quadrants? Good. So 0 and 1 are my little quadrant things. So again, I'm going to label this. And can I tell where my cosine is at 0? 90. So what is 2 times 90? 180. And if you did 2 times pi over 2, pi. Okay, now this one was interesting. I want a restricted angle whose cosine is 1/2. What quadrant is cosine restricted to? 1 and 4, and where's 1 and 2, and where's it positive? I know, I was repeating what you said. I thought you had it right too. 1 and 2, and where is it positive? 1. Oops. 1 and 2. I don't want this guy. I want this. Cosine is x over r. So what's this angle? 60 plus what angle has a tangent of 1?
45.
A 45-degree angle.
Sorry. Jesus.
So these weren't so bad, were they?
Tan has a 45. Wait, what?
Tangent? You're
Oh,
45.
tangent of 1.
Yeah.
I have problems on
Which one? Let's take a look at which one.
8 and 11.
8 and 11. So let's take a look at 8. Guys, you are going to have a quiz on this tomorrow. Okay. It says, and I wouldn't give you this, but this is a good calculator one. It says, here's an angle whose sine is 0.7885. Find the positive angle to the nearest minute. So, since they want minutes degrees, make sure your mode is in degrees. And then, second sine, and put in 0.7885. There's your angle. This is the decimal part for it. Then just go angle, second, apps, and degrees, minutes, and seconds is number 4. There's your degrees, minutes, and seconds. So to the nearest, what does it say? To the nearest minute, you are 52 degrees, 2 minutes. These are your seconds. They work just like a clock. So if it's 60 seconds and I'm 43, should I round this up or leave it? I should round it up. I'm more than a half of a minute. So I have to round this up to 52 degrees, 3 minutes. Okay, these are your seconds. They work just like a clock. 30 seconds would be your half point, right? So it's more than 30, so round that up to 3. Okay, I didn't give you that, but... And then 10. When is it 10?
No, it was 11.
Oh, the same thing. Same thing.
Wait, how did you get to, I forgot how to get to the, minute thing.
Second act. Your second act. Second act is angle.
Second.
Act. The blue word is angle.
There we go.
Act. And it's DMS. Degrees, minutes, seconds. Yes. Were there any other questions on these? Yes. Homework is study for the quiz tomorrow. Yes.